Okay, this is a video to review transformations of functions, which we covered in class today. The first thing I want to review is your table of values for each graph. So there are 6 graphs. I'm going to go ahead and leave y equals x off for right now because I think everyone knows what y equals x looks like. So let's just have y equals x squared, y equals x cubed, y equals cube root of x, y equals square root of x, y equals absolute value of x, and we'll just do those for now. Okay, so these I will say are your maps of where you're going to go when you're graphing these functions. So for x squared, if I put in 0, I get 0, 1, I get 1, 2 squared is 4. For cubed, 0, 0, 1, 1, 2, 8. And then cube root is just backwards from x cubed. So 0, 0, 1, 1, 8, 2. And then we have square root of x. 0, 0, 4, 2, oops, I forgot 1, 1. We can put that in between. And then you can do 9, 3 if you wanted to. And then lastly, absolute value of x. 1, 1, 2, 2, 3, 3, etc. So this is kind of where you're going when you're making these graphs. For example, this smaller. Okay. So for example, if I wanted to graph y equals cube root x minus 1 plus 2. The shape of this is the cube root of x, so we're going to use this map up here. Where am I moving it? This is right 1, up 2. So I'm going to make my origin right 1 and up 2. Now I'm done with the transformations. From this point, I look at my map. My map tells me to go right 1, up 1, right 1, up 1. Then I go back. I go right 8, up 2. And there's my shape. No, that's only half, because remember the cube root has 2 sides to it. So we also have to do 1, 1 in this direction, and 8, 2 in this direction. So notice that the shape stays the same. So let's do another one. Let's say I had, let's do a negative. Negative x minus 2 cubed minus 4. So this will have the shape of x cubed. This is right 2, down 4. Right 2, down 4. So I put that point on there. Now I look at my map. My map says to go 1, 1, 2, 8. Now, this negative is going to tell me instead of going this way, it's going to go the other way. So I go 1, 1, 2, and down 8, which is off the graph. 1, 1, 2, 8. So you're using this as a guideline of where to go after you do the shift, left or right, or up or down. If it's negative, the shape is flipped over itself. It's not necessarily reflected over the x-axis. It's reflected over its own vertex. The last thing we covered was putting a number in front of the function. For example, if I had, let's say, 2 cube root of x minus 1 plus 3. So first I shift. I shift right 1, up 3. Now I follow my map. My map normally would say 1, 1, 8, 2, but I'm multiplying all my y values by 2. So instead of going 1, 1, I'm going to go 1, 2. Excuse me. And instead of going 2, 8, I will go 2, 16, which is off the map, off the graph. Same thing here. 1, 2, and then I'll go 2, 16. So this gets vertically stretched. And remember we talked about this in class as far as someone is pulling the graph, stretching the y values, making them bigger. Let's do one more, just a general graph without a map. This is something we haven't quite covered in class yet, but maybe helpful for some of you. Let's say we have a graph that might look like this. Let's put an arrow there, and then okay, so let's say we have this function. And this is the function f of x. And let's say I want to sketch a graph on the same graph of the function f of x minus 1 minus 3. What would that look like? Well, this would be right 1, and this would be down 3. I don't have a map, but I have a shape. So basically what I'm going to do is move all my points, right 1 and down 3. So take this point, right 1, down 3. Right 1, down 3. Right 1, down 3, like that. We can also stretch or shrink this graph if we wanted to. We could, for example, maybe do something like -2 f of x. Well, in that case, I take all my y values by -2. So if this y value was 3, now this y value is -6. And this y value is 0, so it's going to stay 0, because 0 times -2 is still 0. This is 4. 4 times -2 is -8, so I'll put them down here. So you can see that it got flipped and it got stretched.